Hello, Professor Lazebnik. My name is Sydney Gonsalves, and today I will be presenting to you Huntington's disease. I am in Human Inheritance, Section 1, and today is the 17th of December in 2018. First, I'll be going over the introduction to Huntington's disease, the inheritance pattern, then the molecular pathway, as well as my own personal experience with the disease. So Huntington's disease, it is an inherited, incurable neurological disease. So over time, nerve cells are attacked, causing brain deterioration, and this leads to loss of motor and communication skills and progresses into intense personality changes, depression, but eventually leads to the person's death. So this is an autosomal dominant disease. It is a single gene disorder that follows the Mendelian pattern of inheritance. So it is caused by a mutated HTT gene on chromosome 4, and I just want to clarify that everybody has this gene. This is a gene that everybody has, however, not everybody has the mutation. So this gene is actually, the mutated gene is characterized by an expanded triple repeat of codon CA gene, which is glutamine. So typically those who aren't affected have less than 35 of these repeats, but those who have Huntington's disease have the glutamine repeat over 35 times. So here you see where the gene is located on chromosome 4, and you see how it's transcribed. So we see the start codon as well as the CAG repeats. So as I mentioned before, those who have less than 35 of these repeats do not express are not affected by Huntington's disease. However, when there's more than 35 of these repeats, that's when someone is affected. So when you have this expansion of the glutamine codons, it results in an enlarged HTT gene that causes excess protein Huntington to be produced. So high levels of Huntington are actually really toxic to the brain, specifically the basal ganglia, which is the area that's in charge of motor skills and movements. And unfortunately, there is no exact cause of Huntington's disease that has been discovered yet. However, it's hypothesized it has to do with the proteins HIP1 and HAP2, because as an excess of Huntington protein develops, it's harder and harder for Huntington to bind to HIP1 and HAP2. As well as the aggregation of Huntington suppresses function of other proteins, so this can affect translation, transcription, and whatnot, and then eventually leads to the complete loss of functions in cells. So some treatments for Huntington's disease include a medication called xenazine, which is actually it's actually known as tetrabenazine, but it treats the involuntary movements of the disease. There's also another drug called haloperidol, which is a neuroleptic medication that moderately suppresses involuntary movements in early stages of Huntington's. However, this is an incurable disease, so a lot of times these medications just suppress the movements and help delay the movements. However, it is not a cure. So a lot of times therapy is very common among Huntington disease patients. So these include physical therapy to maintain agility, occupational therapy to help the individuals affected deal with the course of the disease, speech therapy, as well as just counseling overall to help them deal with the trauma of having the disease. There's also other experimental trials, just because people that have Huntington's disease often kind of look at this as a last resort and oftentimes are kind of traumatized and don't really know what else to do. So there are different experimental trials that are going on today. So now I'll talk about my family that's affected by Huntington's disease. So the man over to the left is my step-grandfather who passed away last November, and he's married to the woman in the middle, which is my grandmother. He passed away of Huntington's disease last year, as I mentioned before, and he had it my entire life. My earliest memories of him were actually visiting him in the hospital, but as time progressed, his condition got worse and worse, and he eventually had to move into assisted living completely. He was not able to do anything by himself, which was really traumatizing. Now, we don't know if he passed on the gene to my uncle and my aunt, who are my mother's half-siblings. However, they don't really want to get tested, which is really detrimental and very unfortunate. However, if they do have the gene, they will start expressing the symptoms within the next few years as they're approaching middle age. So in conclusion, this is a really detrimental disease that really tears families apart, unfortunately, and it's really tragic to see kind of the decomposition of loved ones. Hopefully, we will be able to pinpoint the exact cause of Huntington's disease in the future, as well as help out those who are suffering from Huntington's disease. However, this is a very intense neurological disease that demands a lot of attention and a lot of research. Thank you. And I'd just like to thank you for teaching this course. I had a lot of fun this semester, and I thought it was a really great course just to get a general understanding of human inheritance, and I really hope you enjoy your break. Thank you, Professor Lizebnik.